All right, in this video I'm going to go over the basics for graphing exponential functions, just day one, okay? So just as a quick review, all right, last week we learned this equation right here, which is one of the exponential equations, and it has two parts. It has A is the initial value, and it has B is the growth factor. All right, this is what we kind of played around with last week on the Desmos activity and then with what we did on Friday. So what we're going to do is we are going to graph functions in that form. All right, so we're going to skip 3. We're going to come down here for a second. Okay, so we're going to graph the function y equals 2 to the x, okay? And we're going to do that by looking at its value with a bunch of different exponents. So you can put all these into your calculator, but this is 1, 2, 4, 8, 16, 32, 0.5, 0.25, 0.125. Okay, that's all those values. So that's the values for a bunch of different inputs for x, okay? And we can use those values to make points that we can put on our graph, okay? So if we input 0, we get an output of 1. If we input 1, we get an output of 2. If we input 2, we get an output of 4, and so on for all of those points that we have above. Not bad. So we've got all these points, and now we're going to put all these points on our graph, okay? And you can see how this function kind of grows quickly, all right? And kind of how it like shoots off the graph. When we go back to the left, though, it gets very, very small, okay? And so this is our graph right here. And the question is, as we go to the left over here, right, because it's pretty obvious what happens on the right, all right? To the right, this shoots off to infinity. Okay, it goes all the way up to infinity, all right? So just filling in a couple things, all right? In behavior, okay, as x goes to infinity, so we're talking about on the right side of the graph, f of x goes to infinity, all right? It goes straight up. Range, right? We know the range is going to be to infinity because we know we have an arrow going up. We know domain is going to be going to infinity as well. We have an arrow on the right side, okay? So we know all those things. But what's happening on the left, okay? Well, what we're doing, so as we move to the right, we're multiplying by 2. We go from 1 to 2 to 4 to 8 and then to 16, right? So it's doubling as we move to the right. The next number would be 32, 64, 128, so on and so forth, okay? And so that's easy. But if we look to the left, right, it's actually the opposite. We're dividing by 2, right? So this is 4 divided by 2 divided by 2. This becomes a half, or we could say 0.5, 0.25, 0.125. And the question is, if we keep dividing by 2 over and over and over and over again, what happens? And the answer is that your number keeps getting smaller and smaller, but it's always a decimal. It's always positive because you're dividing by a positive and you have a positive, so it can't be negative. And it never actually reaches 0 because it gets smaller and smaller and it gets closer to 0 as we go, but it never actually touches 0. And so we kind of get this situation right here, okay? And this is actually something new that we've never seen before, okay? On the left side of our graph, it actually approaches 0, all right? It gets infinitely close to 0. The difference could be 0.0000000, you know, forever 1, but it never is actually going to touch 0. So domain, all right, so our domain, so we do go off forever to the left. So our domain is going to be negative infinity to infinity. But our range is going to be 0 to infinity, all right? Because the lowest value is 0, and it never actually touches 0, so that's why we don't use a bracket there. And this concept, all right, of your curve, your graph, coming really, really close to a number but never actually touching that number is called an asymptote. Asymptote. Okay. And all exponential functions have asymptotes, right? And asymptotes are actually lines. And so this asymptote is at the line y equals 0. We can draw a line here. Actually, I don't like that. Anyway, we could draw a line here at y equals 0, and our curve would never touch that line, no matter how far you went. And you can go to Desmos to see that for yourself, okay? So that's how you graph one of these functions, right? You've got your starting value, and then you're kind of multiplying, all right? So we can look at a different one. Here we have y equals 1/2 to the x. This one's a little bit different. It's decay instead of growth. And if you put the points in, you can kind of look at it. These are the values of the points. So you notice the numbers are the same as the other one, but they're just in different spots. So this time we're starting at 1 still. This is 2, 4, 8, and then 0.5, 0.25. So it's kind of the same situation. It's just flipped, okay? This is decay, so our numbers are going like this. And what is that? What is happening, right? So now instead of multiplying by 2, we're multiplying by 1/2. So as we go to the right, our numbers are being cut in half each time. As we go to the left, they're doubling, so that's why it gets bigger on the left. So what happens, so our end behaviors have switched, all right? Now if we look on the right side of the graph, now we're approaching 0. So we've still got that same asymptote, all right, at y equals 0. And as we go to the left side of our graph, our arrow is shooting up to infinity, so it's going up really, really high, okay? And so that's decay. So both of these graphs, it's the same thing in reverse, all right? So domain is still the same, all right? It's still negative infinity to infinity. Range is still the same. It's still 0 to infinity. And the asymptote is still at y equals 0, all right? So we haven't really changed any of that stuff, all right? And so the way that I want you guys to graph these functions, now you could do it by hand. Yes, I'll show you how to do it by hand as well, but you can use Desmos, and you want to put in your graph. So we got y equals 1/2 times 4 to the x. And remember, we can turn that into a table, and we can just get our points from our table, all right? So we need a 3. So once we've got our points, we can copy those down. So this is 0.03, this is 0.1, 0.5, 2, 8, 32, okay? And so if you look at our parts, we can see, okay, our a value is 1/2, so there's our starting value, or our y-intercept. And then our growth factor is 4, so we're multiplying by 4 each time. So if you didn't want to use Desmos, you could just know what goes in here, because that's going to be your a value. And then just multiply by 4 over and over again. To go backwards, you have to divide by 4. So you don't actually need Desmos, but it helps, okay? And so you can put these points on your graph. So we've got 0.5 as our starting point. This is 2. This is 8. And then the next number is like way off the graph. We go backwards. We've got like 0.1 and then like 0.03. So you can't really fit too many points on here, but we're going to go ahead and make our graph. All right, and there we go. So this is actually moving up even faster than this one, because it's multiplying by 4 instead of 2, so naturally that's going to be a little bit faster. So end behavior, all right, again, not really that different from normal growth functions. It's on the left, we've still got our asymptote over there at y equals 0, so it's still approaching 0. On the right, it's going up to infinity. Domain is still negative infinity to infinity, and in fact, it always will be for exponential functions. And range is still 0 to infinity. So that's basically this is what I want you to be able to do on your own. Put it into Desmos, get the points, answer these questions based on your graph, all right? So you've got a short practice. It shouldn't take you very long. I'm going to try these questions, all right? And we can go over them tomorrow if you have any questions. If you have any questions that you want to know like immediately, you can send me a message and let me know. And have a great day.